motion. So now that we have our 3 equations of motion, come on, let's do some word problems together. A car is traveling at 30 meters per second and takes 10 seconds to accelerate to a new speed of 35 meters per second. What is its acceleration? Use the first equation of motion, v equal to u plus at. Here, final velocity v equal to 35 meter per second, initial velocity u is equal to 0 meter per second, and time t is equal to 10 seconds. Putting these values in the equation, we get 35 meter per second is equal to 35 meter per second plus a into 10 seconds. 10a is equal to 35 minus 30 is equal to 5 meter per second. A is equal to 0.5 meter per second square. So, the acceleration is 0.5 meter per second square. A brick falls off the top of a wall under construction and drops into the bed of sand 14.5 meter below with an acceleration of 10 per second square. It makes a dent in the sand 185 millimeter deep. What is the speed of the brick just before it hits the sand? Here, since there is no mention of time, we use the third equation of motion. V square minus u square equals to 2as. Here, the initial velocity is 0 meter per second, as the brick just falls from the rest and has no speed of its own. We have to calculate v here. V square is equal to u square plus 2as equal to 0 plus 2 into 10 into 14.5. This will be equal to 290 meters per second square. Therefore, v is equal to 17 meter per second. Amit is waiting at a stoplight in traffic. When it finally turns green, Amit accelerated from rest at a rate of 6 meter per second square for a time of 4.10 seconds. Determine the displacement of Amit's car during this time period. Given information is initial velocity is equal to 0 meter per second. Time is equal to 4.10 seconds. Acceleration is equal to 6 meter per second square. Using the third equation of motion, we get s is equal to ut plus at square divided by 2. S is equal to 0 into 4.10 plus 6 into 4.10 square divided by 2 equal to 0 plus 3 into 16.81 equal to 50.43 meters. Displacement of Amit's car is equal to 50.43 meters. Today we have learnt all about the equations of motion, how to derive them, and finally how to apply them. That was a good job. The 3 equations of motions are: first, v equal to u plus at, second, s equal to ut plus at square divided by 2, third, v square minus u square equal to 2as.